So today we're moving on to a new topic. We're going to start to talk about mediation for the first time. Everything that we've talked about the past few weeks has pertained to interactions. We've talked about interactions that involve categorical and continuous variables, interactions between two continuous variables, interactions in logistic regressions where our outcome is categorical. But the past few weeks, the past few lectures have been exclusively focused on testing for interactions and then making sense of them. Remember that interaction is synonymous with moderation. So everything we've done in the past month or so has dealt with moderation. Today we're going to start talking about mediation. We're done with moderation. We're moving on to something new. But before we do that, I want to be really clear about the difference between moderation and mediation. These are very similar terms, but very different concepts. And I hear people, even professors, I've even reviewed manuscripts where the authors get these terms mixed up, and it's not a good thing. So I want to make sure that everybody is crystal clear on the difference between moderation and mediation. All the examples we've looked at recently have been examples of moderation, where we have two variables that are related to each other, x and y, and we have a third variable, a moderator, that tells us under what conditions are those two variables related. So a moderator tells us something about the strength or the direction of the relationship between x and y. Maybe, for example, the moderator tells us that X and Y are related for women, but not related for men. So the thing to remember about moderation is that a moderator tells us when, meaning under what conditions, X and Y are related to each other. Mediation, however, is very different. So with mediation, we still have a relationship between X and Y, and we still have a third variable. But if that third variable is a mediator, what it actually does is it explains why X and Y are related. So this relationship between X and Y is an indirect relationship. What's actually happening is that X is related to M and M is related to Y. So M is like the middleman that explains the relationship between X and Y. So an easy way to remember the difference between moderators and mediators is that moderators tell us when X and Y are related. Mediators tell us why X and Y are related. It explains that relationship. A simple example of this. Does money buy happiness? Let's say we ran a study and we found that there was indeed a correlation between income and happiness. Now, if we wanted to test for moderation, we would look for third variables that tell us when those two things are correlated. So, for example, if we found that income and happiness were correlated for men but not for women, that would be an example of moderation. Mediation, however, is if we want to explain this relationship. So let's say we find that income and happiness are correlated, and we want to know why those two things are correlated. And maybe we identify some middleman, some intervening variable that might explain why income predicts happiness. For example, money can be used to buy donuts, and donuts make people happy. So in this case, eating donuts would be our mediator. It explains why income and happiness are related indirectly to each other. So for the rest of this lecture, I'm going to go through one extended example of how to do this, and we're going to see two different methods of testing for mediation. In the next lecture, we'll then go through a few more examples, and we'll go through those examples a little more quickly. Superstition. Everybody knows what superstition is. Superstition has been something that has interested psychologists for a long time, dating all the way back to this guy who you may recognize as B.F. Skinner. So there's a bunch of pigeons in Skinner boxes, and Skinner actually wrote an article called Superstition in the Pigeon. And he noticed that when he fed his pigeons at completely random intervals, the pigeons started to develop superstition. such that whatever behavior they were engaging in right before they got fed, they would start doing that behavior more because they would think that that behavior is what caused them to get food, when in actuality they were just getting fed completely at random. So you can kind of see how this might apply to humans too, right? If you're wearing your lucky socks or whatever, when something good happens, you might attribute that to your lucky socks and then wear them again in the future when you want something good to happen. In other words, Skinner says superstition is just seeing a relationship where no relationship actually exists and trying to repeat a behavior that we think produces a positive outcome, but really the outcome was just random. There's been more modern research on this that shows that maybe there's actually something to this superstition effect. Maybe we actually do benefit from having these superstitions. So what I'm going to tell you about now is a series of 3 experiments. We're going to focus mainly on experiment 3, but a series of 3 experiments where researchers wanted to see whether having a lucky charm actually helps people perform better. So in the first study, they brought people in and they essentially had them play mini golf. They gave them a golf ball, there was a hole, and they looked at how many putts they could make into the hole. Half of the people just did this without any further instruction with a regular old golf ball. The other half of the participants were given what they were told was a lucky golf ball. So you have one group with a golf ball that they just say is a regular golf ball. The other group gets a golf ball that they're under the impression that this is a lucky golf ball. Interestingly enough, the people who thought they were using a lucky golf ball actually did better. So on average, the people using the lucky golf ball made 6.5 putts. The people using the regular golf ball only made about 5 putts. And as you can see from this independent t-test here and the effect size, that was a pretty sizable difference. So people who thought they were using a lucky golf ball actually did better. In experiment 2, the researchers wanted to replicate this effect. So what they did is they brought people into the laboratory to perform a task. And while they were performing that task, some of them were told that the researcher had their fingers crossed for them. And other people were not told that. Well, when people were under the impression that the researcher had their fingers crossed for them, they actually completed the task, they solved the puzzle faster than people who didn't think that the researcher had the fingers crossed for them. And again, pretty sizable effect here, right? So maybe there's something to this. You know, thinking that someone's pulling for you or thinking that something is lucky actually seems to be benefiting people's performance. In the third experiment, they wanted to see why this was happening. So they now have 2 studies where they replicated this finding that people who thought, you know, that this superstition was working in their favor, they actually did, in fact, perform better. So here you can see a little excerpt from the study, or from the paper rather, where they say, you know, they set out to extend those first 2 studies. They wanted to go beyond just demonstrating that superstition benefited performance. They wanted to look at the mechanisms. In other words, they wanted to start to investigate why exactly having a lucky charm benefited people's performance. Here's where they're talking about mediation, right? They're assuming that having a lucky charm doesn't directly benefit your performance, but there may be some other variable, some mediator that explains why having a lucky charm actually made people perform better in these studies. And the variable that they identified as a potential mediator is self-efficacy. So their hypothesis is that yes, lucky charms benefit performance, but the reason that lucky charms benefit performance is that lucky charms increase a person's self-efficacy, and then in turn, people with higher self-efficacy perform better. See how self-efficacy kind of explains that relationship. So that was the mediation hypothesis that they set out to test. Now, as promised, we're going to talk about 2 different ways that researchers can test for mediation. The so-called old way and the so-called new way. This is the old way. So you can see from the date that this article was published, 1986, this is sort of the classic way that researchers have tested for mediation based on a very influential article by Barron and Kenny that talked about the distinction between moderators and mediators and explained in 1986 terms how to test for each of those things. So here's how they describe what mediation is. You can see from this diagram, we've got a relationship between our independent variable x and our outcome variable y that is mediated by some third variable. So it's an indirect relationship where the independent variable affects the mediator and then the mediator affects the outcome variable. In other words, they said it accounts for that relationship. It explains that relationship. Their model of testing for mediation involves doing 3 separate regressions, and they identified certain conditions that needed to be met in order for us to be able to say that there is mediation happening here. So rather than having you read the original article, I've distilled it down for you. Here's the conditions that Barron and Kenny said need to be met. Okay, the first thing we need to do, here's our setup. We've got our predictor variable x, we've got our outcome variable y, and we've got our mediator m. So in this case, it would be superstition, performance, and self-efficacy. First, they said you need to do a simple regression showing that x is a significant predictor of m. So all we're going to do is something we did way back early in the beginning of the semester. We're going to run a simple regression. X is your predictor, y is your outcome. I'm sorry, m is your outcome. X is your predictor, m is your outcome. And the first condition that needs to be met is x needs to be a significant predictor of m. So in this case, superstition needs to be a significant predictor of self-efficacy. The second condition that needs to be met is we have to show that x predicts y. So x is going to be your predictor, y is going to be your outcome. This will be another simple regression. Assuming that relationship is significant, then the second condition is met. The third condition, we need to do a multiple regression, where we use both x and m simultaneously to predict y. And what Barron and Kenny explained is that if there is evidence of mediation here, what we will find when we use both x and m to predict y is that m will predict y, but x will not. So only m will be a significant predictor of y and x will not anymore once we add once we add m as a second predictor. This diagram, which we've already seen a whole bunch of times, is a pretty common way that people report the results of mediation analyses. So much so that there are some coefficients that usually get put on these arrows that we will get from SPSS, and we will always report in our results whenever we test for mediation. We use the letter C to indicate the total effect of x on y. By total effect, I mean the simple regression where we have x as the only predictor and y as the outcome. And again, we'll see examples of this later today. This pertains to the second of the 3 conditions on the previous slide. We use the letter A to denote the effect of x on m. So this again comes from a simple regression where x is the only predictor and m is the outcome. So this A pertains to the first of the 3 conditions on the previous slide. B is the effect of m on y. Now we will get B from the multiple regression that is in the 3rd bullet point on the previous slide. Same with C prime. C prime is called the direct effect of x on y. So when we run that multiple regression to check the third criterion on the previous slide, we're going to use both x and m as predictors of y. That one multiple regression will give us the values of both b and c prime. Okay? So those three regressions that we saw on the previous slide are going to give us a total of 4 coefficients, which we're going to put on this diagram. Those 4 coefficients are actually going to tell us quite a bit about the nature of this relationship, as we'll see later today. All right, so let's run this analysis. We know how to do simple regressions. We know how to do multiple regressions. So we don't really need to learn anything new to test for mediation using the old school Barron and Kenny method. So using the LuckyCharms.sav data file, for each participant in this study, we have 3 pieces of information. We know, did they have a Lucky Charm with them, yes or no? So by random assignment, some of the participants had Lucky Charms and some didn't. Second, we know their self-efficacy score. So when they showed up to do the study, they were given a self-efficacy scale, and we know how high or low their self-efficacy score was. And then lastly, we have their performance on a memory test. So this was the measure of performance that was used in this study. Higher positive scores indicate better performance on the memory test. So here's what our model would look like. Our predictor is whether they had a Lucky Charm or not. Our outcome is their performance on the memory test. And the mediator is their self-reported self-efficacy score. So if the researcher's hypothesis is correct, what we should find here is that the relationship between having a Lucky Charm and performing well on the memory test is mediated by self-efficacy. In other words, having a Lucky Charm increases your self-efficacy, and then having high self-efficacy means you have higher performance on the memory test. Here are the 3 regressions again that we're going to need to run. 2 simple regressions and 1 multiple regression. First, we're going to run a simple regression using x to predict m. Second, we're going to use a simple regression with x predicting y. And third, we're going to do a multiple regression where we include both x and m as predictors of y. And we're going to see if those conditions that were laid out on the previous slide are met when we run these 3 things. Okay? So first we have to show that x is a significant predictor of m. So again, we're just going to run a simple regression here like we've been doing for quite a while, using Lucky Charm as our predictor, self-efficacy score as our outcome, and we see that having a Lucky Charm does indeed predict self-efficacy. T is positive, telling us that people who had a Lucky Charm had higher self-efficacy than those who didn't. And this beta right here is going to be our A value. So this is the number that's going to go on that arrow in our diagram that connects X and M. The second condition that needs to be met is that we need to show that X predicts Y. So again, we're going to do another simple regression here with Lucky Charm as our predictor and performance on the memory test as the outcome. And again, we see a significant positive relationship. So people who had a Lucky Charm did better on the memory test, significantly so. The coefficient here is C. So this number right here, 1.68, that is the number that's going to go on the arrow that connects X and Y to each other. Lastly, we're going to do our multiple regression. So we're going to include both X and M as predictors of Y. And again, if there is mediation going on here, what we should see is that in this multiple regression, M is a significant predictor of Y, but X is not. So here's the results of that multiple regression. Here's our 2 predictors, Lucky Charm, X, and self-efficacy score, M. Our outcome is performance on the memory test. and we see exactly what we expected to find. So Lucky Charm is no longer a significant predictor of performance, but self-efficacy is a significant predictor of performance. And here are the last two coefficients that we'll need to complete our diagram. So this number, 0.07, is the one that we'll put in where C prime goes. This number, 0.94, is the one that we'll put in on the B arrow, which connects M and Y. So now that we've run these three regressions and we've shown that all three of these conditions are met, we can conclude, using Barron and Kenny's method, that self-efficacy does in fact mediate the relationship between Lucky Charm and performance. And here's how we'd write that up. First, here's what our diagram looks like. All these numbers came from the corresponding highlighted places on the previous slide. So A and C come from the two simple regressions. B and C prime both came from the multiple regression. There is a diagram on our website. So in the same way that I gave you the Excel file to help make a graph, there is a blank mediation diagram that you can use to fill in these numbers. So what you'll need to do is fill in the names of the three variables in the three boxes, and then fill in the three numbers, the four numbers along the three arrow paths. As you've probably become accustomed to seeing by now, the number of asterisks next to each number shows us the significance level. So C prime was not significant from the previous slide. 2 asterisks usually means P is less than 0.01, and 3 asterisks means P was less than 0.001. So this one diagram and these four numbers actually tell us quite a bit about this relationship. But we also want to add some explanation of this, so we can break down those three regressions. First, we found that the presence of a Lucky Charm predicted self-efficacy, that's our A path, and it also predicted memory performance, that's our C path. But then, when we included both Lucky Charm and self-efficacy as predictors, self-efficacy predicted performance, which is our B path, but Lucky Charm did not predict performance, which is our C prime path. What this tells us is that we have mediation here. Self-efficacy explains why the presence of a Lucky Charm benefited performance. It is the reason why those two variables are related. Now you'll see down here in blue, I have written that self-efficacy fully mediated this relationship. Let me quickly explain, in a minute I'll explain exactly what that means, but you can have full or partial mediation when you're working with this. Okay. Let's take a closer look at these numbers on this diagram. C prime is the direct effect of X on Y. If we wanted to find the indirect effect of X on Y, what we would do is we would take A and multiply it by B. So in this case, if we took 1.73 and we multiplied it by 0.94, we'd get this number down here, 1.618. So a good way to check ourselves to make sure we have the right numbers here is that our direct effect, C prime, plus our indirect effect, which is A times B, should be equal to our total effect, which is C. So if we add these two numbers together, we get the value of C. In other words, the total effect is always equal to the direct effect, C prime, plus the indirect effect, which is A times B. Okay, as promised, the difference between full and partial mediation. I told you in the last example that we found evidence of full mediation, but I haven't yet explained what that means. If we have full, or sometimes called perfect mediation, what happens is that the relationship between X and Y completely goes away in that multiple regression. So when we use X and M both as predictors of Y, the relationship between X and Y is no longer significant. And that's what we saw in the example we just looked at, right? When we included both Lucky Charm and self-efficacy as predictors, Lucky Charm was no longer a significant predictor. It went away. In other situations, though, that relationship may not completely go away, but it may just get weaker. And if it gets weaker, we have what's called partial mediation. So if we had run that multiple regression and found that even when we included both predictors, Lucky Charm was still a significant predictor of performance, we would have evidence of partial mediation there. Now, we're not going to get into this, but just so you know what it is, there is such a thing as it's called a Sobel test, which tells us whether the addition of the mediator significantly weakened the relationship between X and Y. You don't see those used very much anymore, but should you ever see a Sobel test, that's what it actually is talking about. Okay, that completes our look at the old way to test for mediation, the Barron and Kenny way, which involves those 3 regressions, checking to make sure those criteria are met, filling in those numbers on the diagram. More recently, however, we've come up with a better way to test for mediation, and it's written by someone who you might recognize, Andrew Hayes, the creator of the SPSS process macro. About 10 years ago, he wrote an article where he said, I have a new way of testing for mediation that is better than the way that Barron and Kenny proposed. So he pointed out in this paper a couple of problems with Barron and Kenny's method for testing for mediation and how his new method was going to solve that problem. So the first and probably most important problem is that the Barron and Kenny method actually never directly tests whether there is significant mediation or not. What it does is it tests all these other criteria and infers that there is mediation if those criteria are met. But it never actually tells us whether the indirect effect, the A times B relationship, is significant or not. So in Hayes's approach, which we'll see again uses the process macro, we're actually going to measure the indirect effect and test it directly. So instead of inferring that there is an indirect effect from all this other sort of tangential information, we're actually going to test the indirect effect and whether it is or isn't significant. Second, Hayes pointed out a problem with the Sobel test, which is that it assumes that the indirect effect is normally distributed. Process doesn't rely on a normal distribution. You might remember way back in the fall talking about bootstrapping as a modern technique that kind of circumvents the need for a normal distribution. Process takes advantage of bootstrapping. So even if the variables that we're dealing with aren't normally distributed, we don't have to worry about that because Hayes's method relies on bootstrapping. Finally, Barron and Kenny assume that we can only have a significant indirect effect if the total effect of X and Y is significant. Hayes said no. Hayes said you can still have indirect effects even between 2 variables that aren't related to each other. So that was another way that he kind of built upon what Barron and Kenny did. So let's see how we can use process to do this same exact problem. So we're still with the same data, luckycharms.sav, but now instead of doing it the Barron and Kenny way, we're going to try doing it the process way. Here's what your process window looks like. We're used to seeing this by now. We know that our X variable is going to go here. So here is Lucky Charm in the X variable spot. Performance, memory performance in this case, is going to go in the Y variable spot. And our mediator, M, is going to go in the mediators box. So up until now, we've been working with moderators. So we've put our moderators down in the W box. Now that we're working with mediators, our mediator is going to go in here. Another important difference. With model 1, we were testing for moderation. Now that we are testing for mediation, we have to use model number 4. Model number 4 is going to allow us to test for mediation. And again, there are 3 variables. So we put our 3 variables where we need to go. We choose the correct model, model number 4. There's one more thing that we're going to do before we run this analysis. And that is, in the options menu, we're going to check the box next to where it says Show Total Effect Model. And I'll explain on the next slide or so what exactly that means. But it's going to get us some helpful information for our write-up. Okay, so when we run Model 4 in process, the first thing we're going to get is actually all 3 of those Barron and Kenny regressions all at the same time. So all 3 of those regressions that we just ran one at a time over the past couple slides, process is just going to give them all to us all at once. So this first one up here tests whether Lucky Charm is a significant predictor of self-efficacy. This second one is the multiple regression. So we have both Lucky Charm and self-efficacy as predictors of memory performance. And then the third one down here tests for the total effect. So it tells us, do Lucky Charms predict memory performance? The reason it's important to get this output is because this is where we get all of the coefficients that we're going to put on our diagram. Okay, so here is our A coefficient, 1.73. Here is our C coefficient, 1.68. And here are B and C prime. So there's C prime is 0.07 and B is 0.94. So it's doing the exact same thing that we just did, but it's doing it all at once instead of running the 3 regressions separately. So if we wanted to, we could stop right here and report the results using the original old school Barron and Kenny method, and we have the information to fill our diagram. But Hayes' process method goes one step further. If you scroll down just a little bit more, you will find a section called Total Direct and Indirect Effects of X on Y. Here's our total effect. So this is our C value, and it tells us that the total effect was significant. Here's our direct effect. So this is your C prime value. And this p-value tells us that C prime was not significant. Okay, so before I go any further, I just want to stop there. The fact that C is significant and C prime is not significant tells us that we have full or perfect mediation. In other words, this relationship completely goes away when we factor in the mediator. If this were partial mediation, what we would see is that both of these were significant, but this one was just weaker. Okay? Here, it gets so weak that it actually completely disappears. Now, the next part of the output is actually the most important part of the output for testing mediation using process. What this number is here is the indirect effect. So this number is equal to A times B. And if you want to double check me, you can flip back to the previous slide. If you multiply A and B, you'll get this number. Now, as I mentioned a few slides ago, the process method uses bootstrapping to estimate a confidence interval around this indirect effect. Here are the lower and upper boundaries of that confidence interval. So, based on this analysis, we estimate that the indirect effect is equal to 1.62. And the 95% confidence interval for that indirect effect stretches from 0.71 to 2.61. In other words, we are 95% sure that the actual indirect effect is somewhere between these two numbers. Now, this part in green here is the single most important part. When we look at this confidence interval, all we have to do is ask ourselves, does this confidence interval include 0 or not? If it doesn't include 0, What that means is that we have found a significant indirect effect. In other words, if this confidence interval doesn't include 0, we have proven mediation. If this confidence interval does include 0, we cannot conclude that there is an indirect effect. We cannot conclude that there is evidence of mediation here. So in our results, it will be important not only to report the diagram with the 4 A, B, C, and C prime numbers on it, but it will also be important to report this confidence interval and show whether it does or doesn't contain 0. So here's what that write-up is going to look like. First, here's our diagram again. Notice the numbers are the same, but we can get those same numbers using process. And here's our write-up, which has very few numbers in it. So as shown in figure 1, self-efficacy was a significant mediator of the relationship between the presence of a lucky charm and memory performance. Here, we actually say what the indirect effect was. Usually it's called indirect capital B, but what it really is just A times B. So 1.73 times 0.94, 1.62. We could also just get this 1.62 number from that output on the previous slide. We also provide a 95% confidence interval for it. Again, all these numbers are coming from the bottom of the previous slide. Here's the lower and upper boundaries of the confidence interval. This BCA, you might be wondering, is used to indicate that this confidence interval was calculated using bootstrapping. BCA stands for Bias Corrected and Accelerated Confidence Interval, which is just a fancy way of saying that the reason or the method that we used to calculate this confidence interval was bootstrapping. Because this confidence interval doesn't include 0, we know that this indirect effect is significant. So if we want to explain it, what we'll say is that having a lucky charm predicted higher self-efficacy scores, and higher self-efficacy scores in turn predicted better performance on the memory task. In other words, having a lucky charm helps performance because having a lucky charm makes people more confident, and being more confident makes your performance better. That is exactly what they found in these actual experiments. So this whole time we've been talking about experiment 3, where they wanted to test not only that this happened, but explain why it happened. And here you can see they conducted a bootstrapping analysis and they cite Hayes. And they actually give the indirect effect and they give the confidence interval for the indirect effect. And as you can see, their confidence interval also does not include 0. So it shows that they found a significant indirect effect, and then they actually went on and replicated that effect in experiment 4. So it does appear that this weird relationship between superstition and performance might be explained by self-efficacy. Superstitious things, lucky charms, make us feel more confident, and in turn that increased confidence benefits our performance. In the next lecture, in the next video, I will go through a few more examples of mediation. We'll go through them much faster than we went through this one, but this one I wanted to go through really slowly so you could see every single step of the way.